Now let's discuss some specific landforms created from this chemical weathering form. First off, you're going to get a very pitted, bumpy surface. So think about a golf ball. A golf ball has all those dimples, very similar to what we would find here in a karst landscape area. Further, it's going to have poor surface drainage. What I mean by that is if we get a ton of rain, what's going to happen is those dimples on that golf ball are going to hold and store the water. So we're not going to get a bunch of creeks running into streams and rivers, and so you don't get that natural river formation that I'll talk about later in this video lecture series. So essentially what happens is those little dimples hold that water. And so one of the things you saw in the previous images, these well-developed underground channels that do a good job of moving precipitation through the underlying bedrock. And one of the things you'll note the result of the water table, how it actually lowers because of that. That was noted on the previous images. One thing I'll talk about in this specific discussion is this area of south central Indiana, Bloomington to Bedford to Salem, is an area in which you have an abundance of karst topography. Why? This is where you find limestone close to the surface, which once again goes back to something I just mentioned. So here's the one area in which you have limestone that's rather close to the surface and in many respects exposed at the surface. Four key landforms created from karst topography are caves and caverns, sinkholes, karst valleys, and disappearing streams, all of which I'm going to talk about right now. Here's the area of south central Indiana where you find karst topography. And so we do have these rivers that come through and dissect this karst topography area. But the key idea here is this is where you have limestone very close to the surface. And so these landforms I'm getting ready to mention, you're going to find them within this circle here. First, caves and caverns, and so this is created from, once again, typically from limestone and carbonation. But the idea here is the water table lowers, and so when the water table lowers, what fills in that crack that was previously water coming through there? Air. And so then when it's exposed, we can then now walk in it. So if you've ever been caving in Indiana, I guarantee you it's been somewhere in this area here. So this is simply the water table lowering and exposing the caves and the caverns to humans. One of the things you'll note, though, if you do go in one of these caves and caverns, you will come across some water. So that's still the whole process of percolation, rainwater, and all of that, in which you see essentially carbonation in action. Next up are sinkholes. They are circular, funnel-shaped depressions on the surface. And so key to understanding them is karst below the surface. And so they have these underlying cracks in the limestone that get bigger and bigger and bigger over time. Over time, they can't support the weight above it. So essentially what happens is those underground caverns, they collapse, and then above them, the surface collapses and creates these sinkholes and creates these depressions. Thus, the whole idea of a pitted, bumpy surface that looks a lot like a golf ball. This is an image from south central Indiana. I'll come back to this more in the discussion, but here, although you can't tell, because the whole layer of carpet that we call corn and grass covers these sinkholes, covers this pitted, bumpy surface, and so underneath this, we can just simply tell by looking at this field that there's limestone very close to the surface. Now, when you get several sinkholes all in a line together, what that's going to do is it's going to create an elongated depression, or it's going to create a situation in which you have this karst valley. And so it's a valley, but it's not a valley created because of rivers. It's a valley created from simply depressions all right next to each other that are rather linear, all collapsing, and thus creating a valley. Finally, a disappearing stream or a lost river. Essentially what happens here is a surface stream will essentially go down into a sinkhole, go through the underlying bedrock, go through the cracks, and come out usually as a spring somewhere else. And so essentially the water, the river, it's continued to go downhill. The whole idea, though, went downhill and underground so that you don't see it anymore. So in Indiana and south central Indiana, we've got these disappearing streams, essentially, in which those streams go underwater, then reemerge somewhere else. If you go back and look at the previous image, you can really see the whole idea of a spring and how it lowers the water table, but you can see that lost river idea.